Okay, what we're going to be looking at in Unit 4A4 is electric potential and electric potential energy. I would highly suggest you watch this video a couple of times and you also listen for the nuance because the small things in here are going to be important. So the formula for electrical or electric potential energy, not electric potential, this is electric potential energy, is when we take two charges, we take our constant of 9 times 10 to the 9, and we also take the radius between those two charges, and that's going to give us our electric potential energy. And later on, what we're going to see is a use for this in systems when we talk about conservation of energy, because what we're going to throw in there is kinetic energy and electric potential energy, and we're going to see how we can determine the speed of a moving charged particle. So in the content, they're going to go through a lot to show you how this formula has been derived. I want to talk a little bit about this formula. I hope we can see if we have a positive and negative charge, the force of attraction is going to depend on the charges of these. The higher the charge, the greater a force of attraction. But the other thing I want you to take a look at is the further apart these are, the less the force of attraction. So what we could do is we could move this negative charge so far away from this positive charge that they're no longer attracted to each other. Now here's where the nuance comes in, and this is going to lead us towards voltage. Electric potential, now we're no longer saying electric potential energy, we're saying electric potential is measured in volts, and it's the electric potential energy per unit charge. So there's two ways we can determine this. We've got two formulas we can use. So let's back up. If they use the terminology electric potential energy, we use this formula. If they use the term electric potential, then you're going to either use V equals QK over R, and this is when a field charge is given, and you can also use the terminology EE, which is electric potential energy, divided by the charge when a test charge is used. So if they're saying they're putting a test charge in the system, use this formula right here, and don't forget electric potential energy is equal to KQ1 Q2 over R. You're really going to have to go over this in the content, but these are the three formulas that are sort of important so far in U4A4. Now, what we're going to work towards is change in this electric potential, which is going to be our voltage. And we can get our voltage one of two ways. We can use the change in electric potential energy, which is the same as work. So in a sense, these are the same formulas because work is our electric potential energy final minus our electric potential energy initial. And this will give us the voltage in the system. So it's the electric potential difference between 2 points. So what you're going to see here is movement. Now, in grade 11, what you probably did was you looked at voltage in very simplistic terms. So if you had a circuit, we are not studying circuits right now, but if you had a circuit and you had a 2-volt battery and then you had two loads in the system, let's call that a 4-volt battery. Then this one used up 1 volt, this one would have to use up 3 volts in the circuit because you have to use up your voltage. So we're talking about change of electric potential when we're talking about voltage. So voltage is gained as the electrons go through a battery, and voltage is used up as it goes through the circuit. So our total voltage gain has to equal our total voltage drop in a system. So that's what we're talking about here. This can be very complicated. Make sure that when you're doing this, you know the formulas you're responsible for. So it's 5 altogether. Be sure that you know that you're looking at the nuance in the terminology. Electric potential energy, Electric potential is when you take that electric potential energy and you divide it per unit charge. There are two formulas for that, depending on whether you've got a test charge in the system or you have just a field charge in general. So a field charge would be when you take a particle and you've got a field. It will tell you, they'll say either electric field or they'll say test charge. And if you want to look at voltage, voltage is not a physics term. We look at electric potential difference as our term. These are the two formulas you can use, and in a sense, they're the same formula. They can either give you work done or they can give you the electric potential energy final minus electric potential energy initial.